Hello guys, welcome back to Aislyn Technologies YouTube channel. Today we're gonna see about garbage collection. First, I'll explain you the project first so that you have a clear understanding about this. Yeah, our abstract provides a concise summary of the research study focused on automating garbage classification using CNN. It highlights the significant global issues of increasing waste generation and the need for improved waste management practices. The study trained a CNN model on a diverse dataset consist of five waste categories, namely paper cups, paper, clothes, metal, and plastic. The model achieved a high accuracy of 96% during testing, showcasing its effectiveness in recognizing and classifying different types of waste. The finding emphasized the potential of AI-driven solution in enhancing waste management systems, promoting recycling and reducing landfills usage, thereby contributing to environmental conservation effects. Now I will explain the introduction first. Our introduction is about the introduction sets the context of research by discussing the challenges posed by rapid urbanization and population growth, which has led to significant increase in waste generation in wild world. In cities, a World Bank projection, the global waste is expected to increase by 70% by 2050 without urgent intervention. The introduction emphasized the importance of effective waste management for public health, environmental protection, and promoting recycling. It points out the limitations of manual waste sorting, which is a labor intensive, often inaccurate. The study proposes utilizing CNN, a powerful AI tool for image recognition, to automate waste classification into five categories. The introduction outlines the methodology for developing the CNN model and highlights the potential environment and economic benefits of implementing AI solution in a base. Now I'll explain you the problem statement. A problem statement is about the core issue being addressed by the researchers, the increasing volume of waste generated in urban areas presents significant challenges for effective waste management. It emphasizes the drawbacks of manual waste sorting, which is a labor intensive, time consuming, and prone to inaccuracy, leading to improper disposal and reduced recycling rates. Traditional waste management systems struggle to adapt to the growing complexity of waste types, negatively impacting environmental sustainability. Here, our project aims to develop an automated garbage classification system using CNN to accurately categorize waste into five classes, and then by improving the effectively and accuracy of waste sorting, the project seeks to enhance recycling practices and contribute to more sustainable approach to the waste management. Now I will show you our flow chart. Yeah, here's the objective. Our objective is to develop an accurate classification model and utilize image processing technique and to evaluate our model performance, optimizing model architecture, implementing real-time prediction, and promote recycling waste management and facilitate future research. Yeah, this is our flow chart. First, we will load the data set and we will do pre-processing stuff before giving it to a model. After the model, we will compile the model using compile the model. We will train the model using the CNN. After training, we will evaluate the model using some metrics and then we will make a prediction there. Okay, now I'll show you a training code. You'll have good understanding on this. I'll show you a training code first. Yeah, here is our training code. Before that, I will show you our data set on the class, how much it consists of. Yeah, here's the data set. You can see these are the clothes. I mean, clothes wheel, waist. Let's see this. And these are paper cup. Yeah, like this we are given. Now let's be a training code. Here's our main training. Totally, we have five classes so that I give target equal to 5. This is our data set path. And here, what we have done is we are taking all our data and then we are turning into array format. And then I'm turning array format into a targets, which is called as a categorical. Whether our data, our images will be categorized according to this, and then our path and the data set will be split into train files and test files. Here, it will do a statistical report of your data set, whether how much total categories it has, and how much images totally it has in the data set, and how much testing image and training image it will be printed in the ideal in the shell. Yeah. After this step, if you go into this, where your images will be split into 3D to 4D tensors, because you should, when you are going into a CNN model, you should turn into 3D to 4D tensors. After this, your model will be implemented here. These are the hyperparameters that is given to your model. So your model built, it will be fitted toward your data set, which is fitted in above, where your train tensors and train files are your data sets, which is fitted here. And after splitting, you can see how the model is really shown in the final code. And this is prediction. And finally, you will see how was it go. It shows how whether your model is goodly perfected or not. Let's see in there. And finally, your model is saved as trained model CNN.h5. Likewise, it will save. And we will take this code and then we will implement on our testing code, main testing code. I'll open the testing code. Yeah, here's a main testing code. This is nothing but our data set class. Class time will fetched by this only. And this is what we have done before. In training, we have done our 3D tensors to 4D tensors. The same we are doing here. Because our model is imported from there, so that we are giving input as 3D to 4D tensors for the image. After this, every image will be converted into RGB, and then it will be predicted as predicted based on that model, based on this model. Now I run this, you can see. Yeah, ticket is opened here. Now this is our data set. I select any one of the images here. So you can see this, the detected image is metal waste. Yeah. And these are the original image. And these are the grayscale image, which is generated by our code. And detector is waste. I'll show you for other one. Yeah, I'll show you for other data set. Like oh, it's plastic is good plastic. Nice to see this. Yeah, you can see this. The given image predicted is plastic weight, and these are the reposing what you have done. Yeah, these are original image, and the back side is all rescale images. Yeah, I hope you are clear with this project. If you have any doubt regarding this, you can leave a comment in comment section. And don't forget to like, share, and subscribe. Thank you.